Water management, canals. Planet Earth is a small part of unpredictable cosmos. The stars and planets in the universe apply its force and energy on the Earth as it goes around the Sun. Energy and forces in the space and Earth, along with the destruction of vegetation on the Earth, whether it is through the use of fossil fuels, over-exploitation of underground water, or destroying natural forests, results in climate change causing droughts, floods, landslides and forest fires. We are not the first civilization to go through climate change. Civilizations disappeared or displaced many times in human history through climate change. For example, the eruption of the supervolcano, Toba, approximately 74,000 years ago, led to drastic climate change, destruction of vegetation, pollution of water and adversely affected the human and animal population. Supervolcano eruptions are very rare in number, but they can cause catastrophic change in the climate, and adversely affect the plant and animal life including humans. Modern advancement in science and technology allows us to remove salt from seawater to produce water through desalination at some cost. If energy is cheap as in countries with plentiful energy resources, then producing water from seawater may solve water problems in very dry regions as shown by countries in the Middle East. Lastly, producing water from seawater may become a necessity for the humans to survive in case of a supervolcano or supervolcano's eruption. In such an extraordinary circumstance, the only way humans can survive on this earth is purifying seawater or water contaminated with the acid. Even in the case of Ice Age, humans probably can survive, if we have abundant supply of free energy. The research for energy may be able to help the humans in that area. Rivers, streams, canals, qanats, puquios, aqueducts, bamboo pipes, and field channels. Ancient civilizations used rivers, streams, qanats, puquios, aqueducts, canals, floodways, channels and field canals in their water management strategy for more than millennia. Water and life of vegetation are interdependent. Destruction of vegetation can cause disappearance of the water resources, as well as departure of water cause destruction of vegetation. Water can come from underground and overground. The underground water comes from aquifers and overground water comes from the rain, clouds, and snow. Ancient human settlements near lakes, rivers and streams helped them to meet their water needs for domestic, agricultural, religious and industrial use. Canals, channels, and field channels used to transport water from rivers, streams, lakes, all kinds of reservoirs to distant settlements, agricultural fields, religious institutions, commercial and industry buildings. Where are irrigation canals? In Andean highlands of Peru between 500 and 1100 CE, often carved into steep hillsides, transported water from distant sources to arid regions, enabling the cultivation of crops such as maize, potatoes, and quinoa. This resulted in the water management in the highlands of ancient Peru, by controlling the flow of water for agricultural purposes. Canals are still used for transporting water from source of the water to the place of its use. The water from the Colorado River transported to Phoenix, Arizona using a canal. Canals are used to transport goods, people, raw materials, and agricultural produce. Ancient times, canals helped in communication in flooded areas. Canals and aqueducts brought water to public bathhouses and fountains in ancient times. Canals also used as floodways to divert floodwater from settlements, cities, and agricultural fields. They are also used to moving water from marshlands in low-lying countries, like Belgium and Netherlands, to reclaim land for agriculture. Canals were used for draining settlements and sewer systems in ancient times. Today many of them are replaced by pipes. But they are still used in some countries. River engineering can control the flow of water in rivers. River engineering can redirect the river away from the cities, and also increase the depth and width of the rivers for the easy passage of cargo ships and boats. Canals can also control the flow of water in the rivers, by redirecting the excess water from the rivers during rainfall and snow melt seasons to reservoirs, and other catchment facilities to store water for later use, or redirecting the water to agricultural fields to soak up the soil. Dujiangyan irrigation system in China, constructed 2,200 years ago, also make use of canals to irrigate vast regions of Chengdu Plain. This irrigation system harnessed the river using a method of channeling and dividing the water rather than simply damming it. Canals created using water regulators like aqueducts in ancient times helped to irrigate vast areas of arid soil to convert them to productive agricultural fields. Kalani Grand Aqueduct in India irrigate vast arid regions of South India for almost 1800 years. Qanats, overground and underground aqueducts, puquios, all used to transport water from the underground sources to cities, settlements, agricultural fields, religious and industrial buildings. These underground channels in the dry climate reduce the evaporation of water. Land which became wasteland or land which are devoid of vegetation, due to the over-exploitation of timber, water and soil can be converted into productive food forests, by careful land and water management. In many parts of the world, China, India, and Africa, many of such wastelands already converted to flourishing and sustainable food forests, and forests. The conversion of wasteland to forests is achieved, in some places, through creating huge holes in the grounds and allowing the nature to do the remaining. This resulted in collection of water during rainy or snow-melt seasons in the holes, and the birds and animals which came to drink the water, reforest the region through their droppings. In other places, wasteland recovery is achieved through creating channels and check dams and waiting for the nature to do the remaining. The water released through rainfall came down to the check dams through channels. The check dams forced the water to be absorbed into the soil. Over the years, this activity refilled the groundwater levels, which in turn resulted in the return of birds, animals and vegetation. Many of the forests around the globe are destroyed for the benefit of plantations or through natural disasters. The forest which destroyed as a result of the volcano eruptions may grow back, as demonstrated by the Mount St. Helena volcano. This volcano erupted in 1980 and lava destroyed everything in its path. But today the ash-covered land left by the volcano eruption is covered with vegetation. The destruction of natural forest for the benefit of plantations result in eroding the fertility of the soil through soil erosion, in the long run. Moreover, it also affects the water table of the region. The water table of any region is intricately related to the vegetation in the region. Plantations replacing natural forests yield good return only for few years. After that, the productivity of the plantations require addition of water, pesticides and fertilizers. For a long time, human life on Earth dependent on food produced by big plantations of crops. Such food production is become very fertilizer, pesticide and water intensive. Food forests are in the initial stage as a means of food production, but that may be the future of food production, since food forest is a self-sustaining system, without the use of external water, fertilizers and pesticides. If we match the destruction of natural forests for the benefit of plantations, with food forests or natural forests of the region, before the destruction of the forests, in the wasteland around the globe, then we can probably reduce the impact of destruction of natural forests on climate change. We have accumulated a lot of knowledge and data about weather patterns, geological conditions, climate change, vegetation, animals, and ecological interdependence of vegetation, animals and water supply, through research and development. If we use the knowledge and data we have accumulated over the years in interrelated multidisciplinary fields, to recover the wasteland in the form of food forests, then such forests will contribute towards food security of the world, at the same time contributing to the water management and climate management. Moreover, we can reduce the use of fertilizers and pesticides. Natural forest consist of trees, shrubs, creepers, tubers, animals and natural features like mountains, rivers, lakes, and streams. A food forest which imitate the natural forest, in terms of the flora and fauna of the region, before its destruction for timber or food production. then the impact on the weather patterns due to destruction of natural forests can be reduced. The ancient civilization developed strategies for water management to sustain their communities. The water management strategies developed by the ancient civilization can be reapplied after verifying their current applicability, through using recent 100 years data regarding rainfall, vegetation destruction, solar cycles, geological data, weather data, and using weather prediction software. Many countries around the globe faced inundation of their cities recently. If we plan ahead to capture the water before it reaches the cities, then the future inundations can be reduced. If we use accumulated geological data, rainfall and snowfall data to predict the amount of water released in future, then we can make arrangements to collect the water into cascading connected tanks or reservoirs, like the ancient Sri Lankans, before it reaches the cities or big rivers. Then we can avoid future inundations. The collected water can be used to overcome the bad effects of extreme droughts. Some regions which suffers from extreme droughts and scarcity of water during the summer are experiencing inundations these days due to climate change. This year experienced inundation and flooding in Valencia region, Spain. If there were facilities to redirect and collect the water before it reached the residential areas, loss of life, destruction of infrastructure, and destruction of crops could have been avoided, at the same time saving the water for future use. Thank you for visiting our website. Kindly circulate through links if you like the material here. If you are making use of the material, then please don't copy and upload, it will only clutter the internet. Use the material to extend the field, by adding your experience-based knowledge to it, making our knowledge grow and evolve. If you have suggestions to improve the current water management strategies from your field of knowledge and experience, then share your suggestions through our channels. You can also visit our website, https://confusion.com/ for more articles and videos. Before you leave, please don't forget to subscribe to our channels.